Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the second module of this course, that is process management. So in this module, we are trying to understand how the operating system manages the CPU by providing this abstraction of a process over it, right? So as you can see, this module has been divided into 6 topics, and we are currently studying the first one, that is process introduction. So in this topic, through a series of videos, we are trying to understand what is a process and how does the operating system implement this abstraction of a process over the CPU. So in the previous few videos, I have talked extensively about the process. We now know what is a process and how it is represented, how it is implemented, right? So in the previous video, we talked about the life of a process, and we studied the process state diagram, where we saw the different states in which a process can be in. So basically, we now have a good idea of the life cycle of a process. That is, what are all the activities or states that a process goes through in its lifetime. So I want to extend this topic, that is life of a process, in this video also. There is a behavior of a process that is called CPU IO burst cycle, in which basically a process spends its time majorly on two activities during its lifetime, that is CPU burst and IO burst. So let us understand what is this behavior. This is CPU IO burst cycle in this video. So let's talk more about the life of a process. We studied about the process state diagram in the previous video, where we saw what are the different states that a process can be in. So in this video, we are going to talk about from the perspective of what are the things that the process does. So while doing these activities, it could be in some states, but let's focus now not on the states that a process can be in, but more on what activity that a process is doing, right? So as you can see from this slide, a process spends its time doing majorly two activities. The first one is compute or computation, where the process is executing instructions. And the second activity, the major activity, is IO operation, where the process is interacting with the input and output devices. So basically, you can see when the process is doing computation, it is executing instructions. The CPU is involved in this. There are instructions that are sitting, instructions as well as data that is present in the memory. And here what the process is basically is doing, it is here actually the cpu is fetching those instructions and data from the memory, and it is producing some new data, right? Here computation or the processing of input data is happening in order to produce the output data. So this was the processing or the computation part. And the second activity, that is IO, here the process is interacting with the user for two things. Either it wants some more data, that is when it will interact with the input devices, or the user has some more data to supply, so the process has to take in that data, right? Or it has produced some output, that is output data is there, that then it has to send those data that has been produced to the output devices for the consumption of the user. So these are the two major activities that a process is involved in during its lifetime. And this behavior is basically displayed or conveyed by this diagram. So this diagram is called a CPU IO burst cycle diagram. So this basically says how a process spends its life. Basically, you can see there are two types of burst. One is a CPU burst and the other is IO burst. So what does CPU burst mean? So when we say CPU burst, we mean a time duration where the process is busy doing computation, that is executing instructions on the CPU. And similarly, an IO burst means that in this time period, the process is doing IO operations, right? And it is interacting with the users via input and output devices. So essentially, the life of a process is spent on two activities, either doing computation or doing IO operations. And this figure conveys the same. So here on the horizontal axis, we have the time, right? So basically, the execution of a process starts with some CPU burst. It starts with execution of some instructions, some processing. So then after the initial CPU burst, it might need some new data, because if we don't have new input, then it will always produce the same output, right? So for input is very necessary, new input is necessary. And the second is, if there is no output, then what is even the point of running that process? So after when the process is launched, right, when it starts running, after some time it will require interaction with the user so that it can get new input, some new data so that it can do the processing, right? It could also be some output operation. Once the process has done some input and output operation, let's say it was an input operation, it got some new data that the process has to now process. That is, with the new data, the process will be processing that data, it will be doing some computation, and let's say it produces some output, and or it requires more input data. So again, a CPU burst will be followed by an IO burst, where the process will either get more data from the user via input devices, or send the output that has been produced to the output devices for the consumption of the user. And you can see this alternating pattern. Once user interaction is done, once new data is available, again the process goes back to doing computation on the data, processing that input data and producing output, followed again by an IO burst where the process is doing interaction with the user, and so on. So this alternating pattern of CPU burst and IO burst is called a CPU IO burst cycle, and this conveys how the process spends its lifetime on two major activities, that is either computation or interaction with the users for input and output. And finally, after the last IO burst, there will be a final CPU burst where the process will finish its execution. So this diagram, this CPU IO burst cycle, conveys the two major activities, CPU burst and IO burst, that happened during the life of a process. And the same can be understood via this process state diagram. So let's say a process has been created, it has transitioned from new to ready, and it has been assigned the CPU, right? It starts running for the first time, so it goes to the running state. So let's say it has enough computation, and it won't be terminated anytime soon. So if you look at this running state, then there are three possibilities. Either it can go to terminated, it can go to waiting, or it can go to ready. So we're not interested in the terminated state as of now. So as I said, a process will be either doing computation or doing an IO operation. So if you see from this running state, if we leave out the terminated state, there are only two possibilities. Either it will go to ready and then come back to running, or it will go to waiting, then go to ready and come back to running. So there are two possibilities. Either this two transition loop, that is between ready and running, or this three transition loop between running, waiting, and ready. And this first loop, that is between running and ready, signifies the CPU burst. Here the process is busy doing computation, right? It already has the data that it wants to process. It now has to do the computation. It is busy executing instructions, and if it has the CPU, then it is in the running state. Otherwise, let's say the operating system takes away the control of the CPU from the process because it has executed for enough amount of time, then it will go to back to ready. It will be descheduled. Again, it will get the control of the CPU and execute instructions. It will go back to running state. So it alternates between running and ready, running and ready. And this two transition loop is basically signifying that the process is currently involved in a CPU burst, right? It is doing the computation. The other option to the process is that it can transition or cycle in this three transition loop, that is between running, waiting, and ready. So after a CPU burst, we know that once the computation is done, there might be the case that the process needs more input data, or it has already produced some data that it wants to send to the user for consumption. So it will issue an IO operation. So from running, it will go to waiting, and it has to wait. So why there is waiting in IO operations? So we already know that once the process issues an IO operation, it takes some time to complete. Waiting is because the process is now blocked. Unless, so if we talk about an input operation, unless the data has arrived, the process cannot do further processing. It has to wait for the data to arrive, and it will take some time because IO devices are slow. Similarly, if it is an output operation, the process has sent its output data to the output device, but it will take some time for the output device to process it, right? Output devices are slow, same like input devices. So the process will be blocked. It cannot do further processing unless the IO operation is complete. And just to give you some examples of why the IO devices are slow, you can think of the keyboard, right? If you're waiting for input from the keyboard, the human user types only a few characters per second. And compare this with the speed of the CPU. A CPU can execute millions and billions of instructions in 1 second compared to the human user who only types a few characters in 1 second. So IO devices are slow. So this was one example. Other example, let's talk about the printer. It's an output device. Let's say the process had sent some data, a page to be printed. So the page that has to be printed, the speed of the printer, modern printer, is like a few lines per second, right? A very fast printer would be printing few lines per second, right? So again, compare this with the speed of the CPU. It can execute millions and billions of instructions compared to the few lines that a printer can print in 1 second, right? Another example that comes to my mind is the monitor. The display, the modern display has a speed of 60 hertz refresh rate. When we say 60 hertz refresh rate, we mean that display can displays 60 frames in 1 second, which is roughly 16 milliseconds to display one frame. So within 16 milliseconds, the monitor is only able to display one frame, whereas the CPU can execute thousands of instructions during that time frame. So if you compare IO devices with the speed of the CPU, they are very slow. And whenever an IO operation is issued, it takes some time to complete at the time scale of CPU, right? And that is why the process goes into a block state or a waiting state. And only when the event is completed, then it can go to the ready state. So the point of this slide was to just correlate it with the CPU IO burst cycle. Either the process can cycle between running and ready. In this case, it is a CPU burst, or it can cycle between running, waiting, and ready. This is a IO burst, right? So either the process will be doing computation, or it will be doing user interaction. It will be taking input from the devices, or giving the output produced to the output devices. So CPU burst followed by an IO burst followed again by a CPU burst. This is how the behavior of a process alternates between CPU burst and IO burst, and this is what is called the CPU IO burst cycle. So now that we know what is a CPU IO burst cycle, that is how the process spends its time doing two major activities, let's take an example and understand this in practice. So let's take a simple example of how a user would use any application. Here I'm taking the example of Microsoft Word. And as we go over the user journey, the steps that a typical user would take, right? It's just a hypothetical example. We'll see how the process behaves between, displays the behavior that we just discussed, that is CPU IO burst cycle, how it alternates between a CPU burst followed by a IO burst, and so on, right? So here, as you can see, there are two steps. The first step is that let's say a user clicks on the word icon, right? It double clicks on the word icon, and then what happens as a result of this action is that a blank screen, a blank window appears, so that the user can enter some text. So let's just go over and look at more detail what happened between these two steps. What are the things that happened when the user double clicked an icon and a blank window appeared on the screen. So as you can see here, I have broken down the steps. The first thing that happens when the user double clicks on that Microsoft Word icon is that the user interface software comes into action. The user interface software will locate the program executable file for Microsoft Word. It will find out where exactly the executable file is, which has to be run or launched, right? So this part, that is locating the binary, this is a CPU burst, because here there is no interaction with the user. After the user has double clicked that icon, I'm talking about that part. Once the user interface has received that input, right? So there it is just locating where exactly the file is. It could be searching through some directories, right? So this is where IO devices are not involved. Then once it has figured out the location, so this CPU burst is finished. Then once it has the path, exact path, there will be a read from the disk, right? If the binary is a file, it's an executable file, it will so it has to be launched, it has to be loaded into the memory. So as you can see, after figuring out the path of the executable file, it will be copied from the disk, it will be read from the disk and loaded into the memory to create a process image. So we talked about how program becomes a process in one of the earlier videos. We saw what happens when how the program is loaded into the memory, how the process image, that layout is created, right? So that will be done, and here you can see there is a disk read involved, and this is a IO burst where the disk is involved. Once the process image has been created in the memory, the process is ready to be launched, and then the process will be launched. And what the Microsoft, that application will do internally, once it starts running, it will create the blank default screen that we just saw. So this screen has to be created, right? This has to be, the frames of this screen have to be created. And once the screens, the frames of the screen have been rendered, when I say render, this is, when you say render, this is basically creating the screen. Displaying and rendering are two different activities. Rendering means creating those frames. Once those frames have been created, again, this is a CPU burst. This is a CPU activity. Now it's time for doing an output operation. So the frames will be sent to the display. You can say now the output device, that is the display, comes into the picture. That frames that were just rendered, they will be displayed on the screen, and the user will be shown a default blank window whenever we launch the word processor that we see. So the point of this activity was to show you how the process alternates between CPU burst and IO burst. You can see, first of all, there was a burst, CPU burst, where the process figured out the path to that binary. Then it issued a IO operation. It issued the input operation, to be precise, over the disk, where the program file was loaded from the disk to the memory. After the program started running, it started executing instructions. It rendered the default frames, right? So this was again a CPU burst, and finally, once the frames were ready, they were sent to the display. This was a output operation. This is an IO burst. So now let's see some more steps and continue this CPU IO burst cycle. So now what happens is that once you see the blank screen, let's say the user typed some characters, that is hello world, right? So once the user types that, immediately after pressing those characters, the user is able to see the characters that they typed on the screen. So let's decode what happened during this, when the user typed, and during that time it got displayed on the screen. Let's break down these steps and see how the CPU IO burst cycle is continued. So we had left here whether the default screen was displayed to the user. Now there will be a after displaying the default screen, after this output operation is completed, there will be an input operation where the user types in some characters via the keyboard. So you can see there is received input from the keyboard, some basic text. So after an output operation, there was also an input operation where more data was supplied for the process to do computation upon. So once the word processor has received the characters, then it has to process the keyboard input, right? It will figure out, okay, some characters have been typed and these are some basic characters. So then after processing the characters, after reading the characters, it has to again render those screen frames. In these screen frames, this hello world has to be printed at the appropriate location with the appropriate, you can see, font size, color, all of this frame has to be created according to the current settings, right? So this the word processor will do. It will render those frames. This is a CPU burst. And finally, just like the previous case, once the frames have been rendered, there will be an IO burst where the hello text that we just typed in, the frames with the hello text will be displayed to the user. So there will be an output operation where the display will be involved. So you can see the CPU IO burst cycle is continued. The user typed in some characters. There was an input from the keyboard. Then the word processor processed those text, created the screen frames with the appropriate settings, font color, all of that, font size. Once the screens were rendered, this CPU burst was done. These screen frames were sent to the display for an IO operation, for an output operation. So there was a IO burst, CPU burst, and again an IO burst. Let's take one final example, one final series of steps. So let's say after typing in the hello world characters, the user did a control C, control V, so that the text here gets copied, right? So finally, immediately after pressing control C and control V, the user is able to see that a duplicate of the hello world text appears on the screen. So the text gets copied. Let's again similarly break down the steps into CPU IO burst cycle. So after the hello text was displayed, there was some input from the keyboard, that is there was a control C and control V, and not just the keyboard. First of all, the user has to use the mouse to select the hello text. Once the selection has been done using the mouse, then the user will press control C and control V. So in this case, both the mouse and the keyboard are involved for the input. So this was the IO burst, right? The word processor got the input in the form of this text selected, as well as the operation that has to be performed in terms of characters, that is control C and control V. Once this input has been received, so what the word processor will do, basically it will process that input, right? It will figure out, okay, there was a mouse input which did a selection on a particular text, and after that there was some control characters type, that is control C, control V are not to be displayed. They mean some special operation, in this case copy and paste. So the word processor has to do a copy and paste, copy that text and duplicate that. So a new series of screen frames have to be created where there are two copies of hello world, right? So the word processor processes the input from mouse and keyboard and creates the frames where the hello world text is displayed twice, right? After these frames are done, so again, point is, this is a CPU burst. Once the CPU computation has been done over the data from the keyboard and input, the set of frames that were produced, they will be sent to the display for output. So this is an IO burst where the monitor or the display is involved. So we are done with this example, and you can see how. So we started with opening the word processor. We typed hello world. Then we did a selection and did control C, control V. In these few steps only, you can see how there was a lot of user interaction and how CPU burst and IO burst followed each other. So this is how the CPU IO burst cycle looks like in practice. We understood this with the help of the example of the word processor. So now that we understand the CPU IO burst cycle, we also saw an example. The final point that I want to talk about is that depending on this behavior of alternating CPU and IO burst, processes can be either CPU bound or IO bound. So what is this classification? Let's try to understand this difference between CPU bound processes versus IO bound processes. So basically, depending on the length of the CPU burst, processes are classified either as CPU bound or IO bound. So when I say length of the CPU burst, basically there are some processes which spend more time on doing computation. So it's not the case. So there is a common misconception that if the CPU burst is more, then the process is CPU bound. Otherwise, if the IO burst is more, then the process is IO bound. That is not really the case. The classification works upon the length of the CPU burst, because IO devices are slow and they take that time. They are slow. You cannot have very small IO burst. Once an IO operation begins, it will take some due time, right? So the classification happens on the length of the CPU burst. So you can understand this in this way. Once the process has some data, right? It has done some IO operation, it has the data. How much processing does the like the process that we're talking about does? It could be small computations or it could be heavy computations. When I say small computations, we mean only a few instructions need to be executed and the data is processed. And in heavy computation, there will be a series of computations taking a lot of time. So the CPU burst will be more. So just to explain you with an example, let's say there is a text file, right? So once the text file has been read from the disk, this is the IO operation. What kind of processing do you want to do on this text file? One simple operation could be to just count the number of words, right? So this is one simple operation. The other operation could be to sort all of the words in the file and create a dictionary that is that counts how many words occurred. Basically, it counts how many occurrences were there for each word, the frequency of each word. So you see, this is much more heavy computation as compared to just counting the number of words, right? So depending on how much processing or how much computation that a process does on a given amount of data, that defines or determines the length of its CPU burst. In the first case, in this hypothetical example that we just took, for the same data, for counting the words, it will take smaller amount of instructions to be executed. So CPU burst will be small. And in the latter case, where we had to sort the words and create a dictionary, count the frequency, all of that will take more amount of processing. So the CPU burst for the second case will be longer, and we can say that the second process is CPU bound, because with the amount of data that it has, it does a lot of processing. Whereas the first case, the process in the first case is IO bound, because it is only doing small amount of processing. And naturally, when the process is not doing much of processing, more of its time will be, if you look at the CPU IO burst cycle, the more of its time will be dominated by doing IO. As you can see, this first one is CPU bound, the second one is the IO bound. Here, since the processing times are small, the process is not doing much of processing, right? So this CPU IO burst cycle is dominated by the IO burst cycles, IO burst. Whereas in the CPU bound, although the amount of time to do I operation is roughly the same, there is a longer CPU burst, there is more computations involved, and that is why it is called CPU bound. So this was the difference between CPU bound versus IO bound processes. So guys, this was it for this video. In this video, we talked about the CPU IO burst cycle. We understood this behavior of a process where it spends its time majorly in two activities, either doing computation, that is a CPU burst, or interacting with the user, interacting with the IO devices, doing input and output operations, which is called a IO burst. And the life of a process alternates between this CPU IO burst, right? And that is why it's called the CPU IO burst cycle. So guys, this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.